Alright, today's day 314 of data science. It is also May 28th, 2022. It is a Saturday, and today I'm going to do a binomial probability problem. So you can pause this and read the question and then come back. Even though I always say this is not a tutorial, but I get explain things. I don't know. So I'll show you how to do this really quickly and then I'll explain. So I'll do from SciPy import stats. I'll do stats.binom.cdf. I'll do k and p, and then I'll go here and define those variables. So probability is 1/4. Number of trials is 6, and then k would be 1. And it wants to load. And then I'll do round that answer to 2 decimal places, run that, and we should get that answer. So now to explain. So basically, Ira is a student who basically he wants to know the probability that he answers fewer than 2 questions correctly in the last 6 questions. So this is a binomial probability problem. So what does this mean? It means that we have an event. In this case, it's a question. So each question is an event, and for each event we have 2 outcomes, either a success or a failure. So in this case, for each question we have 2 outcomes. Either you get the answer correct, which is a success, or you get the answer wrong, which is a failure. So in this case, we have to know how many events we have, and so the amount of events that we have is n, so the number of trials, right, the number of questions, and we have 6 questions, right, last 6 questions, and then in those last 6 questions we want to know the probability that he answers fewer than 2 questions correctly. Now don't make the mistake of putting 2 for oh, by the way, I have it as k here because in Python it's k, but in your normal math class, this would just be x. So x is the number of answers Ira correctly guesses in the last 6 questions. And we're looking for those number of answers that he correctly guesses being fewer than 2. So it's not 2, it's not less than or equal to 2, it's fewer than 2, meaning 1. So basically the probability that he answers at least 1 question right is what we're trying to look for. So don't make the mistake of putting 2, because then it'll give you like a different answer. So x or k would be 1. So again, k is it's the number of answers Ira correctly guesses in the last 6 questions, but generally it's usually the number of successes that we're looking for. So in this case, the number of correct answers that we're looking for. N is the number of trials. In this case, is the number of questions that we have, which is 6. And then P is the probability of a success, or in this case, the probability of getting an answer correct, which is 1/4. And we get that from here where it says each question has 4 possible choices, 1 of which is correct. So 1/4, which is 0.25. So we could also put 0.25 instead of 1/4. And then to actually calculate the answers, we're using a stats function from the SciPy library. So libraries are full of pre-written functions that we can use, and a function is basically something that you can call and it'll do some fancy calculations for you and it'll give you an output. It'll return an output for you. So we're using the SciPy library and we're using its function stats, and from stats we're using its method binom.cdf, which is basically the same thing as binom.cdf in your calculator. But it takes in parameters a little bit differently in a different order. So it takes in k and p in that order. So in other words, it would be x and p, but in your calculator it's a different order. But in Python it's k and p, and the way I remember is by just, it's like, I remember this by just thinking of like texting. Like usually when someone says, oh thank you, you say like k, or like k no problem, or like no problem, but I think of it as k no problem, like okay, and no problem, so k and p. So that's how I remember that. And it'll return your answer, and I just did the round function, rounded it to 2 decimal places because it wants to round to the nearest hundredth, and then it gives me 0.53, which if we go to the actual question and we go scroll all the way down, there we go, the probability that x or k is less than 2 is 0.53. So we see that happening. The reason we don't use there's an option in your calculator that says PDF. The equivalent to PDF in Python is PMF, which is probability mass function. And it basically, that you use when it's asking you for a certain amount of questions that are answered exactly. So for example, if they ask what is the probability that he answers exactly 2 questions, then you would use PMF, because PMF calculates the probability mass function at exactly that point. But since we're trying to find less than 2 questions, then we want to use CDF, which is the cumulative density function, which basically takes the cumulative probabilities up until that point that you specify, which in this case is 1. Yeah, so I think that covers it. Let me try one more. Okay, how do we go? Wait, no, I want to go back. Whoops. Can I go back? Alright, so let me take a screenshot of this. Oh, this is perfect. This is a PMF problem. Alright, so I'll go down here and paste that in there. Okay, so Heather has a coin that has 60% chance of showing heads each time it is flipped. She's going to flip the coin 5 times. Let X represent the number of heads she gets. So what is the probability that she gets exactly 3 heads? So first things first, I always just like to write my code. And then just have my stuff here so I can fill it out real quick. So K and P, remember K, no problem. And then have, let's say, stats.binom.cdf, and then K and P. All right, okay, and then I go back to the problem. So what's my K? Again, K is your X. It's basically the number of successes that you're looking for. So Heather has a coin that has 60% chance of showing heads each time it is flipped. It's usually in the question. Let me just skip to that part. So what is the probability that she gets exactly 3 heads? So exactly 3 heads is PMF. Forgot that part. So 3 is what we're looking for. So that's our K, or in other words, our X. So let me write that here. So it's the number of successes. Is that how you spell it? We're looking for. Is that how you spell success? Successes. Great. I'm not a speller. Anyway, then N is the number of trials. So in this case, it's let me write that down. So number of trials or events. In this case, it's the number of heads, or sorry, number of coin flips. So how many coin flips? What is the probability that she gets exactly 3 heads and she's flipping the coin 5 times? So N is going to be equal to 5. Okay. Let me do this. So this is the number of heads we're looking for. So usually you know what context it is, because usually heads would be a success, but you know if it's a success if it gives you the probability or the chance of getting that thing, or like getting that outcome. So that's how you know it's a success, because we're always looking here. The P is always just the probability of a success. How do you, the day that I can learn how to spell, I don't even know. Of a success. Is that how you spell it? Success. It's such a weird word. It's a probability of a success. So in this case, it's a 60% chance, so that means it's 0.60. And then again, stats.binom.pmf, because we want exactly the probability of it getting exactly 3 heads. And then that's going to give us an answer, but we want to round that answer. From SciPy, import stats. So we want to round that answer to 2 decimal places to the 100th place. So we'll do round. So round takes 2 parameters, right? What you want to round, and then how many places you want to round that to. So 2, round that, and then we'll wait. Well, it's 0.35, isn't it? Okay, so 0.35. So we'll go here, and it's right. Okay. I always like to take a screenshot because I always like to know that my answer, well, if my answer was correct. I always like to log that so I know that I can reference the code. Anyway, let's try one more. How about that? Ooh, nice. Did we do one like that? Greater than? We did one. Yeah, okay, so good. We did one less than, and this will be one greater than. And we did on one exact, so this is good. All right, so let me do this one. All right. So let me do a horizontal rule, paste that in there, add some code. Okay, so let me set up my template here from SciPy import stats. Oops. It's stats.binomial because we're working with greater than, and it's k, n, p. And then I'll go here and set up my variables. So k, n, and then p. Whoops. Okay. So let's read the problem. So Marta makes 90% of free throws she attempts. So I already know that my probability of success is 0.90. I already know that what my trials or events are free throws. She's going to shoot 3 free throws, so that's n. And then assume that assume that the results of free throws are independent from each other, which is a condition that has to be met in a binary situation. Let x represent the number of free throws that she makes, so that's k in Python. Find the probability that Marta makes at least 2 of the 3 free throws. So we want at least 2. At least 2. So that means we can put 2 as k. In contrast to the first one where it asked us less than 2, this we had to do like 1 because it was less than. It wasn't like equal to that number, so we had to do less. If it asked us to be greater than 2, then we would have to do 3 for k. But because it's greater than or equal to 2, then we can put in 2. And yeah, so again, let me write some notations here, or some notes or annotations. Notations, what? Is it even a word? Notation? Yes, it is a word. Okay. K is the number of successes. I cannot spell that word. Oh my god. You're kidding me right now. Successes we're looking for. And if you're wondering why I always repeat so much, it's because that's how I learn. Anyway, like reinforcing ideas, you know? So number of successes that we're looking for, it would be k. In this case, it's the number of flip throws. Of what? What was it again? And now my thing is frozen. Great. Free throws. I really called it flip throws. Wow, sorry. Okay, free throws. Marta makes. Okay. And then n is the number of trials or events. In this case, it's the number of free throws Marta shoots. And then the probability of a success in this, probability of a success of, I cannot speak, of a success for each event. So in this case, it is the probability of making a free throw in one shot, if that makes sense. So like in one free throw, what's the probability of making it, you know? So run that just to have some notation, and again round it to the second decimal place, right? And then there's one more thing we have to do. Notice that it says greater than. So in Python, there's a little caveat. So usually anything with CDF calculates the probability below or less than a certain point you put in this case 2. So if you have any problem that wants the probability of something of a certain point x or k being greater than a certain number, then you would have to do 1 minus that, because CDF calculates the probability of anything less than or below a certain point. So yeah, basically, yeah. Anyway, yeah, so I can't even speak. Why do I keep saying yeah? Okay, 0.73 is the answer. Hopefully, or hopefully not. What is it now? 1 minus that sign of CDF greater than, is it not? 0.27. 0.27. So what's the issue? Let's try to figure this out. So 1 minus that's binomial CDF, because I know it's like that. And it's K and P. So K is the number of successes that we're looking for. So it's 2. So it's at least 2. Okay, and then N is 3, and then P is 0.90. So what's the issue? K and P, and it's not PMF, is it? It shouldn't be PMF, because PMF would do okay, what's the issue? .97? Really? Huh? 1 minus dots dot binom dot CDF K and P, and it's 1 minus, and it would be K, because K is 2 greater than 2, greater than or equal to 2. Then you would do 1 minus that, and N is 3, and P is 0.90. So I'm not understanding. What's the issue? Oh! Wait, makes 2 plus makes 3. Oh! Because there's only 3. 2 out of the 3. It's P makes 2 plus 2 makes 3. That's the probability of getting x plus 2. Oh, well then in that case, I could have just done the following. Hold up. I could have just done stats.binom.pdf. PDF, K and P. So it would have been what? K would be 1 time, would be 2, N would be 3, P would be 0.90. PMF. Alright, and then this would be the probability of 2. And then the probability of 3 would be stats.binom.pmf 3.90. And so then I would do P2 plus P, the probability of 3, and it would give me 0.97.2. If I round, it's just 0.97, which is it the answer? 0.97.2, yes. But tell me how though, why am I not getting that over here? Find the probability that Martin takes at least 2 of the 3 free throws. So we want at least 2. There's 3 free throws, and there's a 0.90 probability. So, okay, the problem is definitely has to be with K, because N and P are set. Like, there's nothing to argue. Or it's the 1 minus. What if I do 1? Really? Even when I'm doing interesting. Interesting. So if I do, but it said greater than 2, greater than or equal to 2. So if I think about it graphically, if I graph it and I look for the probability of x is greater than or equal to 2, and I do 1, then it goes all the way up until from 1. Oh my god, bro. Hello? Oh, okay. Alright, so for a second there, you couldn't hear me. Anyway, where were we? So yeah, apparently I'm trying to understand why is it that we do k is equal to 1 and not k is equal to 2? If it's equal to 2, that doesn't make sense. Graphically, if you do the probability that x is greater than 1, greater than 1, greater than 1, the probability that x is greater than 1, it would graph the line at 1, no, greater than or equal to 2, so it would graph the line at 2. So we're putting 1, we're doing 1 and up. Greater than or equal to 2 though. Oh, is it not inclusive? Does it not take in that 1? So it does 2? Interesting. Let me search that up. Stats dot binomial dot cdf. If the number is left out, the result is... Why can nobody tell me an answer? Discrete. So blah 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 blah. Let's see. X and P. You know what? I think that's the only explanation. So if I wanted to do greater than or equal... Okay, so greater than or equal to 2, I would have to do k is equal to 1. K is equal to 1. Let me see. Let me just draw this out real quick. Where's my tablet? Alright, let me do... Probably should not have opened that one. Okay. Alright, so... What was I going to do? So if I have a... Because it is a normal distribution. And I have like 0 and I have 1 and I have 2. And I'm trying to find the probability that x is greater than or equal to 2. Then I'm trying to find this greater than or equal to 2, and so that's what I would do. I would do stats dot binomial dot cdf, and I would do k is equal to 2. So I would do 2 number of trials and 0.90. But apparently, and I would do 1 minus that. But apparently that doesn't work. What does work if k is equal to 1. But then that would actually look something like this. unless it doesn't take in 1 and it just takes in the next number. But that doesn't make sense because when doing less than, you want to go to the next number and then it takes, I'm so confused. When we're doing less than, oh my god, yes, it makes sense because when we did x is less than a certain number, I think it was 2 or 3 or something. Let me check. What was it? Less than 2, yeah. We did x is less than 2. We had to put in k as 1. And then that calculated the probability because it didn't include 1. So that makes sense. But then greater than or equal to 2. Greater than or equal to 2, I guess we also have to put in 1. So it's not inclusive. So basically whatever number I put in k, it's not going to include. So if I want p of x is greater than or equal to 3, I have to put in k as 2. Is that the question? I guess. Let's try it. Let's see. Let's see if that's the case for Python over here. Let's experiment. Alright, so this is the right answer. So let me just... Wait, is it the right answer? Yeah, I did 1 minus... Okay, trials 3.9, x value 1. You're joking me. Yeah, that's what I ended up with, but like still. This is what I want. But it's like, why 1? Makes at least 2, but we can use the calculator to find the component which is p is x to the mode of 1 free throw and subtract the probability from 1. Alright, but let's try... No, move on. Thank you. I want one exactly like we just did. Move on. Move on. Can we try again? I want more problems. This one's less than. I want greater than. No. 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 Oh my god, can I just... Oh, it's gonna give me the same problem. I have to finish it. Just putting in a random thing until I can actually get a problem that is asking me for greater than or equal to. No. Yes, but also no. Should I do this one? Greater than 3, that would be 4. Oh. So k would be 4, greater than 3. So k would be 4. Let me try this one out real quick. Alright, so this one... Okay, where's my stuff? Alright, so from scipy import stats stats.binom dot cdf k and p. What the? Okay. K is equal to n is equal to p is equal to. And so k is going to be 4 because we don't want to include 3. probability of success is 0.60, and number of trials is 5. What now? So if we round that, that would be 0.92. And it's asking for greater than, so that would be 1 minus that, which is 0.08. You're kidding me. Can I not round? Is that the problem? Oh my god, bro. Okay, so it's not that, so it's probably, it can't be 3. Greater than 3? Is it because it doesn't include it? 0.34? Interesting. So it doesn't include that number ever. So if it's greater than 3, so then what the, so we, okay, so if it's, when it's less than is when we want to do that, but when it's greater than, we don't want to do that. Interesting. I'm just trying to figure out the rules here. Okay. So k is 3, greater than 3, even if it's not equal to 3, because it's not inclusive, it's exclusive, this k here, because it doesn't include 3. So what it's doing is going up into the next number. So if k is 3, it's going to go to 3. And from greater than 3. Oh, yeah, that makes sense. Because we don't want to do 4, because then it doesn't take all of those numbers. But it's discrete. It's not continuous. They're discrete. It's either yes or no. So that's not a good explanation. Let me think. So, okay, so here I had to do k is equal to 3. But then all the way up there, the first question, it was x is less than 2, and I had to put in 1. Because I needed to not less than 2? CDF less than 2. Less than 2. Less than 2. So not including 2. Which is just 1. And that worked. But it didn't include 1? That doesn't make sense. So I'm guessing my findings here is you want to use logic when it's less than, but we want to ignore logic when it's greater than. It just doesn't make sense. So logically, if you want x is less than 2, then you do not want to include 2, and therefore you put 1, and that works when it's less than. But what if it was x is greater than 2? It wouldn't work, because you would have to keep it as 2, because apparently if it's greater than, it's not gonna work. Interesting. Alright, I want to try some more. Alright, so let me copy this. Alright, let's try. Well, this is PMF. PMF is easy because it's just literally one number. At least this is self-explanatory. Watch me get it wrong. Be like, oh, it's so easy, and then get it wrong. Okay, so I'll just do stats. Can't even spell. Dot binom dot PMF. K and P. I'll just do K is equal to 3. N is equal to 4, P is equal to 0.40, K is 3, right? And then it's 0.5, 1.5, 0.15. Okay, at least. Jesus Christ, imagine I got that one wrong. I would be like, I'm done, bro. I'm literally done. I would have been like, that's my last straw. Okay. You're not kidding me, right? Because how is this thing gonna be frozen? Ugh. Ew. Okay, paste that in there. What was I gonna do? Oh, I was gonna do another problem. Okay, next question. Ugh. No, because I'm literally... Oh. Jesus Christ. Alright, so for this one, it's stats dot binom dot... I don't even know, bro. I don't know. I literally don't know. CDF and K and P. And then K is equal to N is equal to P is equal to 1 over 4 because it's 1 in 4 boxes. Number of trials is 5. 1 is K is, okay, less than, so this, okay, so when it's less than, we want to use logic, right? Less than, wait, yeah, less than or equal to 1. 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 0.63. Less than or equal to 1. See, no, because this just doesn't make sense. So when we have greater than or equal to, which I know I did, where is it? Did I not do one? I just did a greater than or equal to. Whatever. No. Oh my god, I'm so stressed. No, because I'm literally not leaving until I get this right. Not that I get this right. I keep getting there. I just don't know how, like, what in the world, how do we determine what K is? Because this is going crazy right now. Because I'm like, yeah, whatever. It's working when when it's less than, but when it's greater than, it's just going crazy. Okay, well, I don't want to do this. I already know how to do this. Can I get another one of those? Just move on. Why is it the same questions? Okay, greater than or equal to 2. Okay, perfect. Didn't we do this already? Yes, we did. Oh my god, it's the same questions. Skip. Oh my, you know what? Maybe I'm just gonna go to sleep because this is crazy. Oh, you know what? Yeah, never mind, because apparently Cat Academy is running out of questions because it's the same questions. I'll just try to analyze this tomorrow and see like what's the pattern here, because some of them, it's usually when it's greater than is a problem, because like it's 1, but that doesn't make sense. You know what? Whatever. I'm just gonna go ahead and get out of here and just literally get out of here. Okay, so I mean, everything is right, but like I want to go back to it. Should I put 100? Everything is right. Well, yeah, everything is right. It's a good place to reference, but like I'm not understanding some of them. Whatever. Anyway, okay, bye.